Hello there. Welcome to module number 4. We're in enumeration. Hey, let's review. So we started with footprinting. We chose a target. It could be an organization, it could be an individual, it could be a computer, it could be an application, but we need to get as much information about it as possible. Then we moved into scanning. And now we're going to look at hosts that are on the network. We're going to look at ports and protocols for those hosts. What services are running on those hosts? And now we're going to take that information that we acquired and we're going to go into enumeration. Let's talk about enumeration. So with enumeration, what we're going to do is we're going to make an active connection, no more passive for this part. We're going to make an active connection to a device, and we're going to snarf down as much information about every port and protocol that we can about that device. We're going to enumerate it. And so this is a very important part because the data that we get is going to allow us to go to the next phase, which is finding vulnerabilities. So let's have a look at enumeration. Now, what we're going to be doing in enumeration is we're going to start with some concepts, and then we're going to move into the different techniques, and we're going to start our first protocol, which is NetBIOS. We're going to move from NetBIOS into SNMP and LDAP, and then we're going to move into NTP and NFS, and then we're going to end up on SMTP and DNS enumeration, and we're going to have a little package after that, a little bag of protocols, IPsec, VoIP, RPC, Linux, and SMB, and then we'll look at some of the countermeasures. So let's get started. Like I was saying, with enumeration concepts, we want to make an active connection with that device. Once we make that active connection with the device, we can take advantage of whatever that protocol that we find is and pull down as much information as we can. Let's have a look over here at the series of types of information we might be able to find out. What's on that network? Are there folders or files that are being shared? What about routing tables? That gives us information as to where packets are moving. And then we have services that we might want to audit and maybe get FQDNs out of SNMP. We'll talk about that in just a little while. And then machine names. We're going to pair those with IP addresses. And then we get users and groups. Maybe we can get that from LDAP or get it from Active Directory. And then applications and banners. So, wow, we can get a lot of intel from enumeration. So let's get started with a little bit into our first protocol for enumeration. Our first protocol for enumeration is good old NetBIOS. I remember when NetBIOS came on the scene. Yeah, that was a long time ago. It was so long ago that in order to communicate digitally, we would chisel ones and zeros into rocks and share them among the caves. No, it wasn't that long ago. But I remember that Microsoft networks were actually very young, and Microsoft had just started to realize that networking was required. And so they built a pair of protocols. One is called NetBIOS, and the other one was called NetBEUI. This was the early 1990s. So yeah, no rocks, no chiseling, but it was still a very early time of networking. So when you think NetBIOS, think old school. In fact, I'm going to take you back even a little bit before that to talk about why certain protocols, when you see them, you need to recognize them as completely hackable. All right, so the first thing we're looking about with NetBIOS is some of the names that you can find. There is a really cool command called nbtstat, and then there are tools that we can use to find out information about NetBIOS networks. Do you have a network at the office? You have Windows systems? It's very possible that you are running NetBIOS. And so when you do an nbtstat, you're going to see stuff like this. You might get host names. You might get usernames. You might get domains and information like that. And for each one of these, there'll be a NetBIOS code. Make sure you know these codes because they may come up later on. And so, for instance, if you get a 00, it's a domain name. You get a 03, it might be that the message service is running for a logged on user. So you have various codes that you want to look out for NetBIOS. All right, so when we're talking about NetBIOS, one of the commands that I mentioned just a few moments ago was the nbtstat command. Let's have a look at that over here. So if you look at the nbtstat command, you'll see we're doing an nbtstat-a. There's another command that you can use on Windows and on Linux called netstat that looks at the TCP/IP stack. nbtstat looks at the NetBIOS information. And so you look at on the left side, if you look at that, you can see we have the same NetBIOS codes we were seeing a little bit before. Also, we have the NetBIOS enumerator. And then at the bottom of the screen, we have IP scanner and, oh, good old Nmap. We'll see that a little bit later. So lots of tools where we can grab information about NetBIOS. Now, if we look over here, there's yet another tool. This is on Windows. So with Windows, you can do a net view. When you do a net view, it looks at all the resources that you're sharing on that device. But there's more than that. In fact, I went ahead and did the command on my computer, net, and hit enter. And when you do net and hit enter, you get a huge number of commands. Let's have a look at that over here. We have net view, net help, net file, net config, net computer, a net local group, net pause, net session, net use. I've used maybe half of these in many different scripts over the eons and centuries that I've been in the computer field. And they're very, very useful. However, there's one thing that maybe hasn't occurred to you, but you'll see this through the rest of the course, and that is this: that network and system administrator tools are hacking tools. So if you are a network or a system administrator, if you are a network engineer, those are hacking tools. Do you know that also dev tools are hacking tools? In fact, most tools that a lot of us use day to day at work are hacking tools. It's just that we use them for our own purposes. So keep that in mind if you see a tool come up that you use on a day-to-day basis. It's a hacking tool. All right, so let's have a look then at NetBIOS enumeration using AI. All right, let's go over here and have a look at it. So what we're going to do in this case is we're going to ask the API, going back to ChatGPT, to leverage that technology and perform enumeration, NetBIOS enumeration on a target. Another one is get NetBIOS info from a target and display the associated names. Enumerate NetBIOS on a target with Nmap. And so we see that each of these commands, it outputs the associate information, giving us group information, giving us the NetBIOS tags, and using Nmap to enumerate these items that we have with this last one with just for NetBIOS is really what we're looking at in this case. But with NetBIOS, we can enumerate with AI, and we can pull information from a Microsoft network. Okay, so this next section is SNMP and LDAP. So let's talk about SNMP first. SNMP is a very important protocol, still used quite often. Simple network management protocol. What's it all about? Let me go draw on the board. We'll do that. So with SNMP, let's say that you have a network. And so let me go get my little drawing tools out, and we will stay with red. I think that'll work just fine. All right, so I'm going to go over to this side over here. And what we're going to do is I have PCs. So this is going to be a PC, and this is going to be another PC. And then I'm going to have a router over here that's at the network edge going out to the cloud or something like that. And then I'm going to have, see this big screen? Let's say I have a big screen in a room with a bunch of people that are working with that information. Here's a big screen over here. Also, down here, I have a little server, or it could be in a data center. And on each one of these devices, I install, we'll put a little dot here, I install the SNMP service on there. So each one of these has SNMP. So in particular, for this router, I want to monitor this interface. If it goes down, it's going to send an SNMP trap over to this little server here. And then the server is going to display the information on the screen and maybe send out information to people's phones or desktop computers or something like that. What if one of these desktops reboots? If it reboots, it might send a trap to that server, and I could tell that that device went down for a little while. So what it's doing is monitoring. There are a lot of different conditions that we can set up for SNMP. And those conditions don't just have to do with that system going down or that interface going down or crashing, but with a lot of other things. Like for instance, I can say send a trap when the interface reaches 90% of capacity. So those are some of the things that we can do with SNMP. And so possibly SNMP will be all over the network. And so I can enumerate the entire network with SNMP and get data that otherwise I wouldn't know. So that is why we can use tools like you see here with SNMP walk. If you look at those numbers on the far left side, they give you the manufacturer. So for instance, if I'm looking at a network card from a specific manufacturer, a specific make, model, year, revision, we get with those numbers and we can tell exactly what that interface is. And then over here with Nmap, I can use a -SU, and that U is for UDP, and then 161, that port is one of the ports for SNMP, and then I can use the -- script and run an Nmap script, and that script is SNMP processes and then point it at a specific IP address and get all the SNMP stuff. It's pretty cool. And once we start getting that information, we can find out interfaces. We can find out machines, routers, firewalls, IDS, IPS, network protection infrastructure, and so on, depending on what access we have to get that information. All right, so now let's have a look at SNMP enumeration using AI. All right, so let's have a look and see what we're doing. We have 3 separate commands that we're using. All of them are based on ChatGPT, pulling that up with the SGPT command. And what we're going to do is start off with a little bit of a command to make use of SNMP enumeration. But in this case, we designate the tool as SNMP walk and to display the results. In this one, we use Nmap. So this is very nice. Let's say that you forgot how to use SNMP walk, but you know it's a really good tool, or you don't remember all of the parameters to run a good Nmap command. Well, you don't have to, because you can run an SGP --chat --shell and ask it to output the results for you. So it makes it quite convenient, and it allows us to make use of tools that either we don't know how to use or don't know how to use them really well. You just ask the large language model to do it for you. All right, the next thing we look at then is LDAP. What is LDAP? The Lightweight Directory Access Protocol. And what is that? Well, do you know that there's this thing called the DAP, Directory Access Protocol? Do you know there's an entire specification called X.500? And LDAP is just a subset of that spec. Also, LDAP is used in Active Directory and other like Linux, Unix directory services, but mainly in Active Directory. So what we can do with LDAP, as you see right here, is we can use that to pull information out of Active Directory, depending on what level of access we have. So we can pull information from port 389 about user accounts, groups, user and group associations. We can get attributes out of user and group accounts. We can use LDAP. In this case, we're just doing enumeration, but for hacking, we can actually use LDAP to create a user accounts in groups. So it's actually a very, very useful protocol. Now let's have a look at this slide, and you'll see that we have other tools like LDAP Search, AD Explorer, LDAP Admin, and Softerra. I have used a lot of these tools in my normal day-to-day system or network administration, network engineering, and these are also hacker tools. All right, let's have a look then at using NTP and NFS for enumeration. Let's start with NTP. What is NTP? NTP, port 123. If you don't remember what port it is, all you have to do is say it like that, and it's easier to remember. What it is the network time protocol. So what you can do with NTP is you can use it to forward yourself to like the year 2050. It's wonderful fun. Actually, you can't travel in time, but what you can do is you can pull information out of time servers using commands like ntp trace, ntpdc, ntpq. What is this going to give you? It's not going to give you information about your network or anything like that as its main output. What it's really going to give you is information about time servers that are on the network. So these time servers synchronize with atomic clocks, and they keep everything in your entire network at the same time. They give it the same time. So that's very nice. So if I do NTP trace or NTPQ, what I'm going to get is things like clock rate, skew, milliseconds, microseconds, all that kind of stuff. But buried within that, I'll get information about IP addresses and hosts on the network. I can pull information out with NTP. So let's go on to NFS. With NFS on Linux, we can use various commands to make volumes available and to share that information over the network. And there are a plethora of NFS commands, but let's have a look at what we're doing on this particular one. So what we're doing here is number one of the basic NFS commands in the far left corner, which is show mount. So what this does is it verifies that there's a shared folder on that system, a shared directory. And then if you look on the right, we're using RPC info. RPC is a remote procedure call. And what it's doing is it's showing us that NFS is running. And then we have other commands that we can run with NFS that give us information about the Linux architecture. And a little bit later, we'll see that we can take advantage of the fact that NFS is running and actually run some really interesting hacks through misconfigured NFS. All right, so let's have a look at SMTP and DNS enumeration. Now with SMTP, what is that? Well, that is a protocol, port 25, that's used for email services on the network. One of the cool things about SMTP is you can use it to tickle ports. You can say, hey, little port 25, give me a little bit of information back when I ask for it. And in this case, we're going to do it in a very interesting way. Often when I mention Telnet, the first thing that comes to mind, Telnet, that's an insecure protocol. We need to get it off the network. But what you see all through this class is we don't use Telnet to get into a Linux server or a Cisco router, but instead we use Telnet to ask a port to give us more information. All right, let's have a look at how we're going to do that over here. So if we go to the far left-hand side here, we're going to use Telnet to dump information out of port 25. How does that work? So we do Telnet, give it a space, IP address, space 25. Depending on the OS and other factors, it's going to be a little bit different in terms of how you display the port. But either way, we're going to run that. And then down here, you'll see this on all three of these columns. You get a hello. It tells you, hello, how are you? And then from there, it doesn't actually say how are you, but hey, you can imagine it. Down here, we're going to run the command. The first command we see on the far left is verify, VRFY. This is old school stuff. And the reason that we exclude extra letters is because if you go back into the 8-bit days, you really needed to have as little space as possible taken up by commands. So this is verify. And so what verify does is it validates the user. So let's go way back to module number 2, where we're pulling information, for instance, from LinkedIn. We don't know the email address. So we take the person's name and we run verify over and over again until we get a pleased to meet you, verify Jonathan, and it gives you the designation, super user or some type of user, right? If it's the wrong user, if you go down here, it'll tell you a user unknown. So we keep on moving through the users until we find what we want. All right, let's look at the xspin command. If you look at xspin, and this is actually not as informative as I would like it to be. So let's do a different one. Let's say that on the website or the company website or whatever it is, that on that site, there is an email address, info@nymailserver.com, right? It's info at. And so what I do is I do xspin info, and then it'll tell me that that info account is aliased to Jonathan. So I can uncover that alias. And so that's what that does, is it will show the actual delivery address that you see right there. And then the last one here, it defines the recipient of a message. So it's kind of like getting ready to send a fake message to somebody. And in that case, what we're going to do is we're going to receipt to. So we put in the receipt to information, and it should tell us that the recipient is okay. And we iterate through this until we find recipients that work. And then when we find them, then what we're going to do next is keep a record of both the ones that don't work and the ones that work. When you're dealing with pen testing and with hacking, what you want to do is keep records, because you don't want to have to go through, let's say you're going through a database of 5,000 usernames. You don't want to go through and do that again when you miss out on a name that doesn't work, so you want to try something else. You want to just go through your database, find out what didn't work, and go to the next step. Hopefully something that works. Like usual, we have the ability to help automate a lot of what we've been talking about. And like I was saying, sometimes this requires a huge amount of iteration. So if you can allow AI to work for you, you can use AI to make your job simpler. And what we see here is we have a variety of tools. Like for instance, Nmat. We've been talking about that. Metasploit. We haven't talked a whole lot about Metasploit, but we will. And SMTP user enum. It's another very nice tool for SMTP user enumeration and enumeration of many other parts of SMTP. And then NetScan Tools Pro. So we have a variety of tools that we can use. And so what we do is we use our AI capabilities to make use of those tools. Let's have a look here. So what we're going to do in the first case is we're going to say perform SMTP enumeration on this target IP address 1.19. And then what it does is it uses various techniques to pull SMTP information. But this one, in my estimation, is amazing. The reason I think it's so amazing is that Metasploit, I call it the baby universe of hacking. It has so much that it can do. In fact, there are organizations and teams that only use Metasploit. I don't want you to do that. I want you to learn all the other tools. But it is a great tool, and it takes a lot of work to understand it and to be able to use it well. However, LLMs have scanned all the documentation on the internet, all of the examples on the internet, all of the use cases on the internet that have to do with Metasploit. So when you say, yo, LLM, perform SMTP enumeration on target 19 with Metasploit, then it uses the appropriate Metasploit tools, focusing specifically on SMTP enumeration, and it'll do it for you. Pretty amazing. We'll see what we could do even more with Metasploit. Now, we have tools like Metasploit, we have tools like SMNP, Telnet, etc., that we can look at using to enumerate. And now let's look at another protocol. And this protocol that we're going to look at is DNS. DNS is a protocol that lines up domain names, fully qualified domain names, on the internet or host names on an interior network with IP addresses. And what we're going to be doing with those is pulling out information about the network. The more information that you can get from DNS, the better, because you can literally do just about an entire network map using DNS. And we're going to see it come up over and over again in many different ways. But let's have a look at this one. First thing we're going to be doing is we're going to be doing a zone transfer. There are two major types of zone transfers. One is called an AXFR, and the other is called an IXFR. If you want, you could think of the A in AXFR as all records, every one of them. So when the secondary DNS server requests an AXFR, blam! All of those records are sent as one to the secondary DNS server. Now, they're both working together. But as records change, IP addresses change, new hosts, new FQDNs are added to the primary DNS server, it needs to update that secondary DNS server, and that is called an IXFR, or incremental zone transfer. Imagine I am an attacker. I bring my laptop in to an organization, and I'm running a DNS server, and I request an AXFR. And all of a sudden, boom, I have all of the FQDNs, host names, IP addresses of the entire corporation. I can begin to map out that entire company. It makes it much easier for me. So if I can get a zone transfer, that is very nice. Now, if you're familiar with DNS, there are recursive queries, there are iterative queries, and many variants on those types of queries. What we have that you see here is the commands, the basic commands that we use to make DNS work. If you look at the left side of this slide, you'll see that we're looking at Linux. And the primary command looking at Linux is dig. If you look at the right side, the primary command with Windows is nslookup. It's extremely important that you become familiar with both of those commands. And fortunately, we're going to be using them in labs. Now, as I was talking about with the different types of queries, there are two major ones, iterative and recursive. And with a recursive query, one of the interesting things you can do is you can shape the way DNS hands the records back to you. So you can tell it, no, I don't want you to recurse. I don't want to see what's in your cache right now. Or we could tell it to go ahead and recurse, and I want to look at what's in your cache. So what you can do is find out if there's a high TTL value, and it might tell you that the record is not in the cache. Over here, we see that we have an indicator that the query is accepted, but the site is not cached. So in order for it to cache the site, guess what it has to do? It has to recurse, do a recursive query. So we have a way of controlling this. And all of these, or I should say both of these, are part of DNS cache snooping. There is a very nice technology called DNSSEC. And what DNSSEC does is it makes sure that a host, a device on the network, when it's on that network, it won't communicate with any DNS servers except for the designated one. And it's actually very good at that. But even with DNSSEC, that does not stop us from zone walking, finding out information about the zone. So if you look at this slide here, we see we have a couple of different ways zone walking, enumerating DNS to get more DNS information out. One is LDNS and the other is DNS Recon. Both of these can be used to pull information out of DNS. But there are more tools that you can use to enumerate DNS, and one of them is Amass. I like Amass. The version that you see here is the terminal version, but there's actually a GUI version that'll go out and map your entire network. It's actually pretty cool. But even with this terminal version, we can use Amass to enumerate DNS, get network information, get host information, and use it to map the network. All right, the next thing we look at then is using Nmap. And of all the tools we were talking about so far, Nmap is my fave. And so with Nmap, essentially what we have here is this -P. Do you remember what the -P is all about? Yeah, that's designating the port. What port does DNS use? As you can see here, port 53. It's both 53 UDP and TCP. And so we ask it to find that information for us. And for DNSSEC enumeration, we use a script called dns-nsec.enum and another one with script arguments, DNS-nsec-enum, and then we give it the domain. Right? So we can pull information, do DNSSEC enumeration from Nmap. And over here on the left-hand side, we're just doing regular DNS enumeration. And so we're using Nmap, specifying the script, which is broadcast DNS service discovery, and then giving it the target FQDN or even IP address. But in most cases, when you're doing DNS enumeration, you want to start with the FQDN, fully qualified domain name. So Nmap does a very, very good job with that. And then we can take the tools that we talk about and integrate them with AI, use Nmap to perform DNS enumeration on the target domain. And bada boom, it runs Nmap and dumps out the information for us that we can use as we are enumerating the network. And also, we can do cache snooping. So use dig command to perform DNS cache snooping on the target domain, certifiedhacker.com, using the recursive method. Use DNS server IP as, and then you give it the IP address of the DNS server. Another one, use the dig command to do cache snooping with non-recursive, using that method. So we have both of these, and it pulls out records from the DNS server using both of these methods. So if you don't remember how to use Nmap to do a recursive or a non-recursive query, if you don't remember how to use DNS Recon to pull information out of a DNS server, well, you can use AI to do it for you. We're going to see that over and over again as we go through this course. Okay, so in this learning objective, we're going to look at that little basket of protocols I was talking about before, including IPsec, IPsec, sometimes it's called VoIP, RPC, Unix, Linux, and SMB. Now, keep in mind that these are just some protocols. If you were to do a Google search or go to a Wikipedia article on the TCP/IP suite, you'd see that there are hundreds of TCP/IP protocols. We're choosing the ones in this module because they're the most common and the ones that you're most likely to enumerate first. Let's have a look. The first protocol that we want to look at is IPsec. And when I say protocol, I'm wrong because IPsec isn't just a protocol. IPsec is a suite of protocols. And if you've ever had the opportunity to configure a Cisco router with IPsec, that's a difficult configuration, and you have to make a lot of choices as to what type of protocol you're going to use at which layer. We'll get into that a little bit later in the course. But with IPsec, what we're focusing on here is port 500. And that's going to be our IC or ISCAMP port. And that's going to tell us that this service is running IPsec. And so what we can do is use UDP port 500. We can scan with IKEScan, IKE-scan, which you'll find in Parrot Security Linux. And we can use SGP. In this case, SGPT, we're saying to perform IPsec enumeration on the target, and we're specifying the tool with Nmap, and then it's going to dump the Nmap information on port 500, and we know for sure that IPsec is possibly running, I said for sure, but possibly running on that system. There was a time when every time you made a phone call, it was on a phone that had a little curly wire that went to a box that was on the wall that was distributed out to a neighborhood area where you have these 55 or 66 blocks, and we have these pairs of wires that are punched in, and there's this thing called a butt set that you could plug in, and you could listen to that phone call if you knew where to do it. Even in offices, you could do that. But now we have VoIP, voice over IP. So all of the call information is packetized. And because it's packetized, it leaves it open to a variety of very cool attacks. One of the first things we want to figure out with VoIP is VoIP running on that system? So let's have a look at how we do that. So the first thing that we see here is we're running SVMap. SVMap is a nice, very easy to use tool to find out if VoIP is running on that network. Another tool that we can use, as you see right over here, is we're making use of Metasploit, and it has tools that can also find out if VoIP is on the system. Another protocol is RPC. RPC is a LAN protocol. LAN, local area network. I have a client like a PC or a laptop. I have a server like a data server of some sort, and they're communicating over the network using remote procedure calls. Why is it important? Well, because I can find out information about who's connected to that server, IP address, host name, etc. So if I use a -A in Nmap, as we see here, I can get some RPC information. Also, we can use tools like NetScan Tools Pro to get RPC information. All right, the next thing we want to look at is some of the commands for Linux. Now, with Linux, there are only 3 commands that you can use. No, as you well know, if you've been doing the labs, we have all kinds of Linux commands, tens of thousands of Linux commands that are very, very helpful for doing anything you can imagine on a computer. But what we've done is chosen 3 commands that are typical of how we can enumerate users. The first one is users, our users. The second one is rwho, and the third one is finger. Now, of these 3, the one that will dump the most information for you is finger. Finger can give you information about the user, groups, login names, terminal name, idle time, office location, you name it, you can get it from finger. And so a lot of organizations will have that command turned off for a good reason. But if you find one with it on, you can use that to do your primary enumeration. And then you can circle back, as you see here, to our users or rwho to get a list of users who are logged in or get users that have been hosts on this network. SMB. SMB stands for Server Message Block. A server message block, we were just talking about Linux. This is all Microsoft now. Now, if you're on Linux, you'll see it as Samba, SMBA, but on a pure Microsoft network, it's just SMB. If I share a folder on the Microsoft network, I'm using SMB. And I can get a lot of information out of SMB. And later on, we can see that we can hack through versions of SMB that aren't as secure. But let's have a look over here and talk about some of the commands that we can use with SMB. And my all-time favorite is enum for Linux. Have you tried that command? It's really cool because enum for Linux, unlike Nmap, which gives you some specific information, enum for Linux will range widely and get you a huge amount of information about that SMB capability on that server. And then, of course, if you want, you can always do it with AI. And you can tell it to use Nmap. In this case, we scan with Nmap. There are more automations that we can do with AI. And one of my favorite things to do with AI of all time is to use it to help me to create scripts and to code. And that's what we're doing here. Develop and execute a script that will automate network enumeration tasks on the target range of that /24 network. And so what it does is it goes through an iterative process automatically, and then it runs that detailed enumeration on the system. So if you look over here, we're also going to enumerate other network tasks. Look, we get, it's Windows 11. Look, we get the system time. What else do we get? We get user information. Let's go to the other side here, and we get RPC information. So we're getting all of the information that we're just going through, but we're getting it all in one sweep. Furthermore, if you look over here to the right, we are getting that timing information, clock and skew. Remember I was talking about that? And we're pulling out a little bit of information about the computer name. And over here, we're grabbing information on MAC addresses and so on. This is still with looking at time. And then down here, we're grabbing user information, a relative ID, usernames, etc. So this script is just churning through everything. So in other words, rather than taking this module that we've been talking about and typing in one command at a time, using one tool at a time, I can just automatically generate a script to do it all. You need to protect yourself and your network from people like me. And by the end of the class, you'll need to do the same for people like you. And that's where we have countermeasures. So let's do an overview of some of the countermeasures so that we can avoid having people enumerate our network. Now, the most important two countermeasures are encryption and identification. And that's what we see in the first set that we look here. So let's look on the slide here. So with SNMP version 3 is the only one that can do encryption. Let's look at LDAP. Startles is an LDAP technology that will encrypt LDAP. But wait, look a little bit lower. And what do you see? Behold, I see a protocol that is older than the hills. Let's talk a little bit about NTLM. One of the reasons why I would never expect to see this as part of a security solution is because of NT and LM, those two pairs of letters. LM stands for LAN Manager. So I had a job way back in the early 90s, and I was running one of the earliest Microsoft networks. And in order for it to work in the data center, you had to have another operating system called OS2 from IBM. And then you ran LAN Manager on top of OS2. And then you had to have Windows 3.0 with an extension in order to do the networking. Why am I telling you this? Because LM means super old. And then about 3 years later, Microsoft came out with Windows NT, first 3.1.1 and then 4.0, which was the most popular Windows NT. Why am I telling you this? Because NT, those two letters are old. So put these two together into NTLM. I mean, it even says NT LAN Manager right there. That is extremely old technology. Why would I have it as a countermeasure for people grabbing LDAP information? Because it's better than nothing. If it was open and unencrypted, and there was no authentication required, then an attacker could just take all of that information. But even if they have to just authenticate with a little NTLM, then it'll take them longer to crack the NTLM if they decide to, and maybe by then we can catch them. So NTLM is actually a solution for authentication for LDAP. For NFS, you want to make sure and secure those NFS permissions. You want to make sure that you block port 2049. You want to make sure that you're careful with logging everything that's happening. For SMTP, you want to make sure and also encrypt that channel if you can. ID that channel if you can. Make sure you don't do open relays for SMB. Make sure you're using the latest version for SMP. Disable port 139 and 445 for SMB, and use the secure SMB ports. For DNS, one of the things you might want to do is random ports. So make sure that when there's a request sent out, it uses random ports, not specifically port 53. And then patch and update your DNS server. So there's a lot we can do to help defend against people enumerating our systems. They're somewhat similar to defenses against scanning. Also in this module, we got a chance to look at multiple protocols, like some of the NetBIOS is one of the Microsoft protocols. We had a chance to look at DNS and look at SMNP, SMTP, and many other protocols, and how to use those to enumerate the network. Now, what we're going to do is we're going to take this information that we've gathered. We've been keeping track of all of it. And we're going to take that and we're going to find vulnerabilities on the network. So stay with me, and we'll do that in the next module.